use the product rule to differentiate g of x equals e to the x times the square root of x. Now we can use the product rule here because this is a product of two functions that we can differentiate. The first is e to the x, and the second is the square root of x. You'll recall that the product rule says that if we're taking the derivative of a product, we can express that as the derivative of the first times the second plus the derivative of the second times the first. And we can use that to differentiate this. So we've got g of x equals, we start with the derivative of the first. The derivative of e to the x is just e to the x, not that bad, times the second function, which is root x. So we've got e to the x root x plus the derivative of the second function times the first. Now we need the derivative of the square root of x. You might remember what that is. You might not remember what that is. Let's do this off to the side in case you don't remember. The derivative of the square root of x equals the derivative of, how else can we write this? X to the 1/2. Now we write it like this so we can use the power rule. The power rule says that we take the power out front and then we decrease the power by 1. So 1/2 minus 1 is -1/2. So this is 1/2 times x to the -1/2. And this is the same as 1 over 2 root x. Because remember that negative exponent brings us in the denominator, and the 1/2 power is the same as the square root. So the derivative of root x is going to be 1 over 2 root x. That's the derivative of the second times the first, which is just going to be e to the x. So again, we can factor out an e to the x. That gives us e to the x times root x plus 1 over 2 root x. Now, we could leave it like this, but we actually can combine these two fractions. We can get a common denominator. The common denominator is 2 root x. So I'm going to keep that e to the x out front, and I'm going to keep this 1 over 2 root x here. But then this, if we want a common denominator, we need to basically take this and put it over 1, and we need to multiply the top and bottom by 2 root x. Now the denominator just becomes 2 root x, but then the top, if we take root x times 2 root x, well, the square root of x times the square root of x is just x, and it's also being multiplied by that 2, so we've got 2x, and so we can write this as e to the x times 2x plus 1 over 2 root x. That is a little bit nicer than what we had up here. The reason for this is that oftentimes once we find a derivative, we need to do something with it. We might need it for the slope of a tangent line or other things, but sometimes we need to set the derivative equal to 0. And having something like this is a lot easier to set equal to 0 because we know that it's equal to 0 when the numerator is equal to 0, and that's a lot easier than taking this whole big thing and setting it equal to 0 and solving. So oftentimes it's nice to be able to combine a couple of terms into a single fraction if it works out easily. And there we go.